Hey there, universe nerds. Few things in the cosmos capture our imagination quite like black holes. They're the ultimate paradox, invisible yet powerful, terrifying yet beautiful. They bend space and time itself, swallowing everything that dares to cross their boundary. For decades, they've lived in science fiction stories as cosmic monsters, but the truth is far stranger than fiction. Today, we're going to dive into the science, the mystery, and the reality of black holes, and by the end, you'll see why they're the most fascinating objects in the universe. So what exactly is a black hole? It starts with a massive star. When such a star runs out of fuel, its core collapses under its own gravity. If the star is heavy enough, at least 20 to 30 times the mass of our Sun, that collapse becomes unstoppable. The core shrinks to a single point of nearly infinite density, called a singularity. Around it forms an invisible boundary known as the event horizon. Anything that crosses this horizon, even light itself, can never escape. That's why black holes are black, not because they're empty, but because they trap everything, even photons. Despite their invisibility, black holes reveal themselves through their surroundings. When gas, dust, or even whole stars get too close, they spiral in, forming an accretion disk. Friction heats this matter to millions of degrees, emitting X-rays that our telescopes can detect. Some black holes also launch relativistic jets, beams of energy and particles blasting out at nearly the speed of light, stretching thousands of light years into space. These jets are so bright they can outshine entire galaxies, all powered by something that doesn't even let light escape. And then there's the size question. Black holes come in different categories. Stellar black holes are a few times the mass of the Sun. Intermediate black holes, harder to find, are hundreds to thousands of solar masses. And at the top of the hierarchy are the giants, supermassive black holes sitting in the centers of galaxies, weighing millions or even billions of suns. Our own Milky Way hosts one called Sagittarius A star, about 4 million times the mass of the Sun. And in 2019, astronomers took the first direct image of a black hole's shadow in galaxy M87, a monster 6.5 billion times more massive than the Sun. But black holes don't just swallow, they also warp the universe around them. Einstein's theory of general relativity predicted that their immense gravity bends space and time. We see this in the form of gravitational lensing, where light from stars behind a black hole is bent, creating rings and arcs. More dramatically, time itself slows down near the event horizon. To a distant observer, anything falling toward a black hole appears to freeze at the edge, stretched and distorted. From the perspective of the falling object, though, it would cross the horizon normally, but would never send information back. This leads to one of the biggest mysteries: what actually happens inside a black hole? Physics as we know it breaks down at the singularity. General relativity predicts infinite density, while quantum mechanics suggests something else entirely. Some theories propose that black holes may not destroy information, but store it on the event horizon, the so-called holographic principle. Others suggest black holes could be gateways to other universes connected through wormholes. None of these ideas are proven, but they remind us how much we still don't understand. And black holes also play a critical role in shaping galaxies. Supermassive black holes aren't just passive monsters. Their activity regulates star formation, influences galaxy growth, and even determines the structure of cosmic neighborhoods. The jets they produce can heat and stir interstellar gas, preventing new stars from forming. In this way, black holes act like galactic thermostats, controlling the pace of cosmic evolution. Without them, the universe might look very different. And just when you think you've wrapped your head around them, black holes throw another curveball: Hawking radiation. Proposed by Stephen Hawking in 1974, it suggests that black holes slowly evaporate by emitting tiny amounts of radiation at the quantum level. For stellar black holes, this process takes longer than the age of the universe. But for small black holes, it could mean they eventually vanish entirely. That means black holes aren't eternal. They're cosmic objects with lifespans, ending not with a bang, but a whisper. So why do black holes capture our imagination so strongly? Because they sit at the edge of knowledge. They're where physics breaks down, where time and space blur, where our understanding of reality itself is tested. They remind us that the universe isn't fully mapped, that mysteries still exist, waiting to be solved. And maybe that's the most exciting fact of all. Black holes aren't just cosmic monsters. They're teachers, challenging us to push science further, to imagine bigger, and to keep asking questions. So next time you see that photo of that glowing orange ring, the shadow of a black hole, remember what it represents. Not just darkness, but possibility. The universe's most mysterious monsters are also its greatest invitations to wonder.